Spence.
I'm going to go ahead and start. You might get people to wander in. Today's presentation is on continuous integration. My name is Jim Rush. For today, what I'm going to do is I'll spend a little bit of time talking about myself and then what is continuous integration. I'm going to spend most of the time today talking about components of continuation. I've actually connected into my office for one of my projects. I'll actually bring up Jenkins and actually walk you through some things that we do with it. And we'll talk about some of the things and how you can leverage continuous integration for different aspects of the process. So, a lot of what I'm going to go through is developer focused. That's because I'm a development manager. My career history has always been wanting to be software development. I happened to get a slow start. I did tech support for a couple of years, and then I moved into development for professional services, which is doing custom stuff for large enterprises. And then about 7 years ago, moved into the product development side of our house. What my company does, and where I've been for the last 17 years as of October 2nd, is call center technologies. That be things like IVRs, things where you call, the bank answers the phone, you get menus, you drive them through. ACDs, calls that route around call centers for anything from 20 seat call centers to a couple thousand seat call centers that may be scattered across multiple locations around the world. We also are an acquisition company. So my parent company, they buy other companies in roughly our space. So over the last 7-8 years, we've bought a company in New Zealand that does something very similar to the call routing technology, just aimed at a slightly different market. We bought a call recording and screen recording company for analytics and monitoring of agents. We bought software that does that works with Cisco and is basically what operators use to route calls around the call center. All these different types of things that are essentially around phones and call center technology. In the last 7 years, since I moved into, thank you, I appreciate it. It's always good to get a little extra help from the outside. For the last 7 years, I mentioned I've been a manager in a product development team. It was a big change for me, but at the same time, they've just changed vice presidents, and he was in the process of trying to institute the changes that you heard Eric talking about this morning. Since we are a multi-location site development group, at that particular time when he started, we were in Phoenix, Chicago, mostly. We also had a group in London. It was really trying. I was the one that was close, so my team tended, and I was doing more greenfield work initially, so I became the guinea pig for a lot of the stuff that we did. We started off with test automation and moved on from there. I mentioned some of the ideas of some of the technologies and things that we had to build CI systems around. Telephony and call control, routing calls and verifying they're working. APIs and user interfaces. On the user interface side, we've done things in WinForms, typical .NET desktop technology, and we're currently doing Silverlight as a web-based technology. I can give you more details around that for those who care. We are using multiple development languages. We're mostly a traditional sort of Java, C#, C++ shop. The majority of our development staff background is C++. They're used to building low-level telephony, talk-to-hardware kind of things. Although over the last 10 years, it's been increasingly all new things are usually Java or C#, mostly from a reliability standpoint. When things break, you've got more insight, more information. You're not chasing memory leaks. Not to mention that those languages are now fast enough usually to manage and route calls around. You still may be doing low-level C++ code for packet transfers and VoIP and things like that, but the higher-level functions can all be done in higher-level languages. We use a variety of different test tools and frameworks. We've changed them out periodically times. We've experimented with a few things. A lot of our technologies have tended to drive us. And I've got my particular team here in Phoenix. I currently have 11 developers reporting to me, ranging from someone that's just a year out of school to someone who's been in the field 25 years. I've got user interface designer and graphic artist reporting to me. I also happen to own our technical publication manager, and she owns the technical writers across all of our product line. A bit of variety of things that I own. My contact information is there if anybody wants. There's nothing terribly exciting on the website unless you like seeing travel photos and some of my side hobby projects. So let's get into what you really care about. What is continuous integration? I'm going to give you the Wikipedia one first, and I'll have to read it myself. Implements a continual process of applying quality control, small pieces of effort applied frequently. Continuous integration aims to improve the quality of software and to reduce the time taken to delivery of it by replacing traditional practice of applying quality control after completing all the development. So the traditional waterfall code it, get it all done, think that it works, throw it over the wall, someone to test it, or customers to test it, and hope that it all works. Simply put, CI is about periodically validating your project. And I've picked those words a little bit more specifically because of what they can actually mean. Periodically is as often as you can. Depending on what you're doing, it may be something that takes 10 seconds to run it every moment. It may be something that takes hours or days to run. You may have to run it in weekends, nights. So what continuous is going to be often is a cost judgment. So you're going to do it as often as you can. And I'll talk a little bit more about that as I get into some of my examples later. Validation, ensure that your project is working. And even just building your product, compiling it will give you a sense of, hey, at least the syntax is right. Execution gives you next layer and different layers of execution, unit tests, integration tests, and system tests. So there's different levels of validation. Maybe doing metrics. You saw some of the presentations earlier with their screenshots showing metrics and data coming out. How much code coverage is acceptable, is good enough? How much kind of issues might be popping up in the code, duplicate code, things of that nature. And the project is more than just what I define as something larger than what you ship. Your project is all the intellectual property that you put together in the process of building the project. So that's the code you ship or goes to your customers. It's the development tools that you may have augmented, build scripts, things to put everything together. It's also install scripts. It's also your testing frameworks. It's also your configuration for all your environments. You need to validate that those things are functional. They definitely gather dust over time. It's amazing things that you think that should just work, and then nothing's changed. You suddenly discover something did change. So continuous integration can be more than just the code that you're shipping. It's validating your entire infrastructure at times. Why? This group, I'm hoping we wouldn't get too caught up on why. Quality is a main focus. But know when you break your existing functionality. Issues are typically easier to address the sooner they are found. It's a classic 101. Issues are also typically easier to address when the number of changes from the last time it worked to now are small. If you go 6 months and have a piece of code that hadn't run successfully in between, you have to go figure out what did you change to break some small little piece. It can be a lot harder. So those iterations of knowing that things are right and knowing the right often enough are important. And definitely decrease the cost of your projects. You also gain visibility into the health of your project. There's a lot of ways that you can do this, but you can see what's happening. Are things working? Is code progressing? Are new features coming in? There was an example earlier in the last presentation about actually allowing project owners to see test cases actually getting done and getting completed to show progress against it. Sprinting and Agile, you tend to have burn down charts to show progress, but all of those types of things are in there. You want to fail fast. If there's a problem, you want to discover it right away so that you can plan for it. You want to know 6 months before delivery date if you have to push that delivery date out, not 2 weeks before the delivery date. So general rule of thumb usually is if you can tell somebody early that you're going to have to slip a date, they got better ways of politically and otherwise to figure out how we're going to slip a date. So common CI components, and this one's an interesting one in the sense that this is some of the classic items, but CI can be a lot less and a lot more. Software repository, so version control. So I'm going to ask a question. I got to laugh when I asked this before we started. Is there anybody in here, not to call you out or too bad, that has a team that's not using version control? That's great. I actually have run across teams that don't.
So have I.
It does scare me. I'll talk. Each one of these items I'll talk a little bit more in depth a little bit later. You typically have a build process. So you grab software, you're building it, you're compiling it, you're assembling it. Maybe you're just warming it up or building out installations. There actually may be some project where literally the source structure is your deliverable. Most systems, though, have some amount of build capability that has to take place. A monitoring and triggering process, so software that monitors when things change, kicks stuff off, and actually does the build, does other things in the process of testing. So we're looking, and then usually also that same process is responsible for reporting failures. So if it's something that says go build, it's usually the thing that also tells you that it built didn't work. Automated testing is a classic component, whether that be unit testing, integration testing, system testing, getting more advanced using accessibility testing like scalability testing. I've even seen some attempts at doing usability testing. And these become tools. They're not necessarily end-to-end. It does it all out by itself, but maybe it helps you or cuts down the manual effort. So for example, in the area of usability testing, walking through a product and grabbing all the screenshots as a certain test case is running things still look like they're flowing right as they're being put together. So you can take advantage of things like that where it still has a human to actually validate the data, but you can automate the process of collecting it. And then a big one that's been important to my organization is metrics. Metrics collection and reporting them. So every group usually has some amount of metrics, or they do the basic ones like executable source lines of code, test counts, code coverage, performance data. There's usually a fair amount of metrics that come out of this. It may even go so far as lines of code developed in a given sprint to story points in a given sprint. All these different things. They may be done in separate tools. You may be able to pull them into your CI environment. You're going to find very much of what I have to say is you're going to look at your environment and go, what pieces of that works for us and how can we pull it in? There's a lot of different ways of doing this. This is just a visual representation of what I was speaking of. We've got version control, build, various levels of testing. The testing order is arbitrary, but typically your unit tests run quickly. They don't have a lot of dependencies. They're designed to be very small, very fast. As you get into bigger and bigger testing and environments, they start to become longer and longer. So you tend to stage them down further. That way, if certain things upstream fail, you can make a decision. Do you actually let the testing keep going on, or do you just stop it there, fix the first level tests and not? We actually have different types of choices in that area. We usually, depending, most of our test cycles will let them complete. In some cases, when we get to our system testing, we've actually got some front tests, and if they fail, don't go any further. Don't go waste the 2 to 3 hours it might take to run the rest of the tests. So we get basically a smoke test build, and then after that, if it seems to work, then we'll run the rest of the tests. All of that generates, every one of those stages can generate reporting, monitoring, metrics. Everything in every part of your process usually has a measurable item in it. Version control itself, activity, who's checking in, when they're checking in. There's a lot of cultural stuff around that. My personal attitude is I don't care about people breaking the build. I'd rather have them check in regularly than wait until the end of a sprint or even just end of their work to discover that, oh, some other parts of code changed and now the merge is going to be even harder. And you'll see that. I'll actually show you our build. And I looked at it this morning and there was a lot more red than I was expecting, but it happens. There isn't a, oh my God, you broke the build, you bring in food for the team for the next week. So, Continuous Integration Manager. It manages the CI workflow. It monitors version control usually. It often handles the continuous inflow workflow dependencies. Dependencies is sort of the tricky one because all these different stages of build, if you were to sort of graph them out, can often be more tree-like than they are linear in pipeline. You can end up doing a lot of things in parallel and then things have to join back up. Also, often they take care of reporting or giving you back feedback information. Common tools for doing continuous integration management. Cruise control was popular a couple of years ago. I would say the current leader one is Jenkins, which you heard earlier, which is also known as Hudson. And as it was discussed earlier, it's really just it's a name thing. Jenkins is the project that people look at. Some people still look at Hudson, so I try to insert both names. Custom scripts and code are actually still out there and are fairly common. I've still seen a lot of builds that will do their own thing for a variety of reasons. I've come across a couple of embedded development teams that still do their own thing, or they just haven't ever gotten out of their old existing build system. Changing out build systems is hard, much harder than you can possibly imagine. The link at the bottom, by the way, if you're ever looking for just lists of automation software, there's hundreds and hundreds of things out there. They all have their different trade-offs. As I said, I've very much become a fan of Jenkins. I've been on it now for about 4 years, and I haven't taken to any of the other ones, mainly because of some of the things it gives me. It's a reasonably friendly web-based administration. But it also uses XML for all this data setting, so you can do mass changes very quickly. So if I want to go off and modify our CI server to go build a different version, a different trunk, I can just do a quick changeover, and so literally in a minute or two, I can swap our entire build server over to another version. The web interface actually makes it useful for anybody in the team to go in there and manage and change the build. Cruise control, which is what we came from previously, had some very complicated, some messy to understand XML files that had to define the jobs. And I found them to be tedious. One item I didn't put in here is that it also deals with workflow dependencies a little bit better. Cruise control was not as good with trying to get build order and controlling build order. I mentioned it was flexible. One feature that I've really come to like, it enables distributed builds and testing. So you can have a Hudson server, you can have 10, and they can all intercommunicate. You can indicate what jobs go on what server or let them pool out, and they'll allocate resources across the environment. We don't do that so much for building, but we do it for testing, because we'll have a lot of jobs for testing, and we can get them to run in parallel across multiple virtual servers as well. So the tests that are tied to particular phone switches or technology will run in Chicago. Ones that for equipment that we have here in Phoenix will run here, and so forth. So that distribution capability has been very nice. It provides plugins for nearly every other tool in the CI workflow. You saw some of the, for those that were in the earlier presentation, you saw some example of that. I'll bring it up and I'll look it through, but from anything from version control systems to the build and test tools, if it exists out there, commercial or open source, odds are somebody's turned around and written a Jenkins plugin for it. So you can usually make it work. It's got various triggers. Occasionally you have more than just I want the build to flow normally. Maybe you want to trigger it for nightly. Maybe you want to trigger it from an external source. You can have, I mean, there's some silly plugins, I'm not sure who really use them, but you can have trigger from a tweet. So why you'd want to do that, I'm not sure, but definitely I've seen other people tied into other environments like calendars and other types of schedules, maybe other things you want to do custom in your environment. And very rich set of reporting components. They'll do a lot of the graphs and stuff for you. And then what I really like is that they'll very quickly allow you to just display an HTML page, which means you can write any kind of code you want to work in that just takes your data or takes your information and generates a report. You can put it up inside of your Hudson display. So let me go ahead and give you an actual tour of our system. I do have in the presentation for those that download, there's actually screenshots, but since I have a live system, I thought I'd actually let you take a look at it. This is one of our CI systems for one of the products that I'm working on. To give you an idea of some of the things that are occurring on the screen here, just basically main features in navigation, ability to create a new job. There's security features that you can set up so you can define user accounts or tie it to an existing account management system. If there's issues, you can have things that are managing for claim. There's some status monitoring, the dependency graphs. Some of these things that you show up here you won't get out of the box. You have to go download or add in other plugins. This is the build queue of jobs that are waiting to run. So as you can see, there's quite a few jobs backed up. This is probably just the result of somebody checking in, or actually in this case, here's a case of a test that went bad. We are using, and you'll see when I scroll down, that we have some problems going on. One of our test frameworks that we're using, it's a third-party commercial product to test our UI, has some stability issues. It likes to occasionally crash. We're working with the vendor to get better versions out. Where we're at now is when we run it in mock mode, we don't actually have to talk to anything under the hood. It generally runs reliably. Every now and then it doesn't. Our system test, where we under the hood have plugins into their test tool, where we actually have to go reset phone lines and reset environments, actually seems to cause regular crashes to the point where we don't even run it through our CI system anymore. I've got developers assigned to, okay, once a week you need to kick off your suite of tests inside of the visual portion of the test studio. So hopefully, though, we're going to, over Christmas, we're going to take another pass at upgrading to their latest version. They've been giving us some support. It's just I can't churn anymore on trying things. Every time we want to separate out and cycle our CI environment version of tools and upgrade them, it's painful. It costs me about 130, 140 hours to go do that versus right now I'm sort of consuming up 10 hours a week manually having people kick off test results and just check them into our database. Across the top, these are custom links that we put into other areas in our product. So we use version 1 for our backlog tracking on this team. Some of our metrics pages, wireframe designs. The latest builds are available up on the web pages, so you can go in there. The big part of the page with all the little buttons, or the balls, are actually the jobs. So the main build job is the one called agent build. The agent asynchronous unit test is the one above it, so the unit test. Everything else below that are automation test jobs. So mostly in the naming scheme that you'll see there is what browser it's running on, in this case IE. If they're running against system live environments or mock, these are essentially running against a mock backend. So it all runs encapsulated within our Silverlight application. Color codes are pretty simple. Green works, red didn't. The weather symbols can be variable depending on how much data you want them to tie to, but they can give you a sense of health. Some things that are nice that you get is you do get when the last success was. So on most of these jobs, most of them, the last success was within the last day or so. I've obviously got one there that has been broken for 3 days. Also, you get if they've been successful, what was the last failure. As you can see, even when the ones that are green, usually within a day or two, somebody's broken and it's a lot of these are UI-driven tests, so as you shuffle around and move around UI, you can correct things. The runtime for all of them together is about 6 to 8 hours. By running them parallel on 2 or 3 VMs, we usually get that down to roughly 2 hours. So I mentioned distribution. Here's a couple of So what kind of stuff can you do? And the other thing I do is I have some metrics and report generation jobs that kick off either once a week or continuously to provide some additional data. Let's see here. Let's make sure I cover. So I'm going to come back. I'll come back into this as I know. I'm going to go into at least one of these jobs. So here, we'll pick into this one that's broken. So this is a more detailed view of a job. So let's see. Disk usage is arbitrary. It's on there, but there's an example of the test results. As you can see, there's at least one test that's bouncing around and may not be working. You can see off across the builds. You can see the time. So we're getting roughly, what does this look like? Across the day, this is all October 5th, so I don't know, 6 to 8 runs a day. That will vary. The builds will obviously cycle much faster because they only take a couple of minutes. Things that you get that are informational is dependencies. So whenever the main project builds, this job fires off. So its upstream project is the compile. The downstream project is it kicks off this one. From the nomenclature of our names, and I guess it's not on two names. And this is testing call interactions, which us is actually taking a phone call and what an agent would do for a phone. This is one. If this one passes, it'll kick off all the other tests associated with call interactions.
What does Chuck Norris do if it fails?
I'll show you.
Chuck Norris, buddy.
So, and I said there are silly plugins for Jenkins. That's one of them. I'm actually a fan of it. What's actually better is you do get Chuck Norris posts that I think are rather funny. Chuck Norris can read all encrypted data because nothing can hide from Chuck Norris. So you'll get some rather entertaining ones in there. From a personality perspective, I actually like to have fun at my job and fool around. We like to deliver. It's important, but I definitely want to have fun while we do it. The Chuck Norris code in this case, Chuck Norris doesn't need garbage collection because he doesn't call .dispose. He calls dropkick. There's a good set of them. There's a bunch of them out there on the webpage. This is one of my more favorite plugins. So that gives you an idea of what Jenkins will do for you. I'm going to cover some of the other cases, and as we come back to it, I'll actually probably walk into each of these. Actually, before I do that, let me show you two useful things.
Are those automation things kicking off after a deployment automatically?
These are kicking off after a code check-in automatically.
Okay.
So the dependency graph on ours is essentially run the build based on check-in. It checks, in fact, I can show you the configuration. Which one? We basically, let me go back to a job where you can actually see the one. There is actually a graph here that'll show you, but it doesn't look really pretty. We have the main job. So agent build is our starting point. Let's open up its configuration. Configure. Pretty. I mentioned it was web. It's got lots of settings like you'd expect it to have. I'll walk down to the settings in a moment. So at the front, we've got a name, project name, description, how much data you want to keep from old builds, whether or not it's parameterized, which means you can actually drive it from parameters and other things like environment variables. So you can actually configure it to build multiple versions. We tend not to find that to be useful for some of the things that we do. Whether or not builds can be done concurrently or whether they should be done one at a time. There's usually no point compiling, continuously or in parallel. You can label it, which then can be used to tie to certain machines. So our builds are always done on the main machine. Testing we have two separate essentially test pods, one for running in mock that don't need to actually be connected to a real infrastructure, and then another pod of stuff that can be done that actually requires live action. I mentioned, so trigger in this case, we're tying to Subversion. So we're telling it to go monitor this node on the Subversion tree, and to check it, where's the actual, down here at the bottom, check it every 5 seconds. Just ping it to see if there's been a change under that node of the tree. And Jenkins will automatically take care of, since you told it where the Subversion code is, it'll automatically pull the source code in, update your code, and then kick off whatever you've told it to do. In our particular case, and we haven't gotten into the build items, but we're using Apache Ant for our build. So I'll come back to some of these other settings here in a little bit. Roll back down. I do want to show one more report. So there's cases where I said we're using a commercial testing tool. We haven't been, the commercial testing tool has its own viewer for viewing the results and so forth. It generates an XML file, a rather large one of all the test detail. We've done work to take that XML file and essentially translate it into two things. One's a JUnit XML file so that Hudson recognizes it, sees it, and virtually every automation tool out of the market that does things with test results can read it. The other thing we've done is to make it more manageable to debug and go for it. Every day in our stand-up meetings, if there's open and broken tests, we'll go through the list and decide who needs to be triaged and we're working on them if somebody already isn't. So this report will often be brought up. So these are all the tests that are failing. These are the test codes. I think I've actually had a quality center that we're using for testing. Test names is based into the rest of our process, and here's the only test in this group that's failing. And here's an example of basically the testing scenario, some of the comments and requirements that are in there. If you click on Aerolog, you actually just get the dump from our test tool. So some people can diagnose it out of here, but the main focus of this is just a quick view of what's going on in the environment. So, where we were at. Version control systems. Here we go. If we already said if you aren't using it, why not? Why to have it? Backups, I guess, would be the cheapest reason I can come up with. Tracking changes to time, person, and feature is useful. I've had times when we had to go back and find out when a bug got introduced. My company maintains 3 shipping versions of any given one of its products. If a bug's been around for a while, we need to go evaluate to apply it to other versions. So we often are having to track it down. It's also sometimes to know why did certain things happen. There's occasional times where something, an issue is big enough that we do a proper deep dive into what happened and why, and to know when code got introduced, maybe even sometimes tied back to what story or who did it, is useful. Not very often, but it is nice. And then obviously to support multiple versions of code. That's, I assume, would be a common thing for most people, that they have to support multiple versions. The other thing that I like about version control is that it's very nice to be able to use to go off and do exploratory versions. You're going to do something that's complicated, something you've never done before. Go off and work on a branch. And if it works or you like it, you want to keep it, merge the branch back into the trunk, otherwise keep it separate. As far as what to use for version control, the only thing I have to say about it is we're on Subversion. If I had to pick it today, I'd pick Mercurial. I would have preferred to be on a distributed version control system. There are a couple advantages of it. There's Git. There's a half a dozen others. Our team in Chicago is on ClearCase, which is a commercial product. They love it. They do. And it does have some of the better merge tools around for doing very they're branch happy. They will branch on every given little piece of work and then merge it back in, and it works well for them. However, ClearCase over a corporate WAN
Is
bad.
not a...
We did remote desktop into a machine to actually deal with it. They're not coming off of it so easy. Some advice about it. As I said, I mentioned I like distributed versus centralized. It comes into use in a couple of key places. Whenever you have stage teams, groups in multiple places, you can actually have separate servers and then do merges against a central one. The one feature that I like about it that you can do is, as a developer, I can have a version control server on my machine. So I can check in multiple versions, iterate as I want to. If I'm messing up, before I've even checked into the main build, I can back up to versions on my own machine. So I can step backwards, I can see diffs as I'm evolving code, check it in, and then from there, when I'm ready, when I've finished enough work towards good, then I can merge that into a main repository. The other feature for it is nice for newbie developers. You can assign them a senior developer. They only check in against the senior developer source code base of their server, and then when that person signs off on it, then you can go into the mainstream branch. So some of the distributed version control tools, there's some special cases that I think are nice, but at the end of the day, it doesn't matter that much, I think. Most of them do fairly good. Probably the most important thing I would say for any of those tools is their merging tools. Some of them will allow you to use other tools for merging. Merging when you're doing a lot of complicated stuff is really, really nasty. It can be very hard to track down the changes. Not to mention if the tools have support for specialized file formats that you deal with. If you're dealing with specialized document types or specialized files, it's nice to know that your tools support it. I'm still trying to find a good merging tool that ignores styling. I don't care if your semicolons and your brackets are one place or another. My version control merging tool should not tell me they care that there's a difference there. It's not a semantic difference. I don't care that somebody switched from spaces to tabs. You do what you want to do, I want to do what I want to do. But most of the battles, I think, over stylage would go away if the core versioning control systems kept a semantic version of it, and then everyone just looked at it whatever way they wanted to. It was efficient for themselves. Ongoing growth, who's being supported, who's not. I can't think that the version has changed all that much, I think, in the last couple of years. Some of the desktop tools, the Tortoise, for example, for doing the desktop management have changed, but aren't doing so much. And then whether or not you care about metrics and that kind of data that come out of it. one thing to note, once you've established a VCS, or any of these things for that matter, they are hard to change. I'm actually, as I said, I'd love to go to Mercurial. I can't get my group to do it. Not my group. I can't get my department to allow me to do it. My VP that's invoked all these changes, one of his drives is about consistency. So he wants consistency of tools. He thinks that if he has consistency of tools, he can move developers around teams more easily. I keep trying to explain to him that that's the easy part. I can teach anybody to use any of the standard tools. Teaching about how my code base works or what they've got to worry about, that's the hard part. But in any case, it can be a struggle to invoke change. So building, I don't know how many people in this room care about development and building, but obviously guys have to create a distribution, compile if needed. Common tools, Apache Ant, Maven, batch files, shell scripts, things of that nature. There's millions of build tools and even more popping up these days. Seems to be the new fad is to create a new build tool. Common challenges. Repositories are intermittent build components. Maven doesn't have this issue. Maven, one of its strengths is it pulls dependencies around from other places and essentially does that for you. Hudson doesn't do anything for you by itself about getting files. If your build consists of six components that are built independently and then brought together in a later build, you'll need to find your own decision on where you're going to put those intermediate files or intermediate components. So those can be put bashed into the version of a repository. I've seen that done. We tend to use common file share, so we essentially publish our files up into that directory. We use the same place to publish all our metrics. Error reporting can be tricky, as in the sense of that most build files are written quickly or written by machines so that they don't always tell you what went wrong. You will spend time debugging build steps when things get really haywire. Builds, by the way, can be complicated. Some can be just really simple. Go compile all this stuff. Go execute this Visual Studio Makefile build. I typically find that they tend to be a lot harder. We're often pulling things from multiple places. We're bringing them in. We're compiling them. We're maybe often making multiple build flavors. We're doing a dev mode, a debug mode. We're doing a production release build. We're doing a demo version or 4 other flavors of demo versions that maybe we're doing a sales version that pre-populates and has some environment. So we're often doing multiple builds. Dependency management can sometimes be a challenge. Most of them are based off the concepts of make, which were simple. This task depends on this task, and it cascades down. They don't always get it right. Sometimes why you'll see build scripts clean everything and build because they can't adequately detect what's changed in the environment at times. Build efficiency is also one that's worth talking about. Depending on what you're building, that can become very important. Java.NET, JavaScript, web applications usually build very, very quickly. You get into C++, C code, and you get build and link times that can be 10, 20, 30 minutes long. Or in the case I mentioned, our ACD project, that whole build, not counting really unit test, is about 4 hours just to build, link, compile, and build all the files. You add in installation, building MSI files or other types of deployments, and they add up. Some of the tools that are out there have things that will help give you profile information. Apache Ant, for example, there's a plug-in to it that will actually tell you how long each task took. I discovered that in we also use Ant for a lot of our testing and our wrappers around that type of work. I discovered that since we run heavily on virtual machines, we were excessively copying data. I was copying help files into places that I didn't need to. And help files were, in some cases, half the size of the project. I shaved off 30 or 40 seconds per build on some of our tests because I just wouldn't copy the help files over. But you can go back and look at it. I typically find if you're working in a virtual server environment, disk I/O is your primary bottleneck. If you're on physical machines, it can vary. But those of you that are in virtual farms, you'll find disk I/O tends to be number 1, which means even doing build up on RAM disks can gain you a lot. Build a complete production, including your installation. The reason why is you want a consistent result. You don't want someone to have to go to Bob. He goes to his machine. He has to run the button and get the magic build out. That's a specialized environment. You want your build environment to be able to consistently result your delivered product. You may not always want to test that. You may want to just test some of the intermediates, but have it automatically generate the full release product with version codes, numbers, everything. In our case, that tends to all the way boil down to setup.exe for some of our products, or basically a war file that might get sent up and included in another project. Invest in quality build scripts. You will spend time at them, usually at the worst time in the project. Make sure they're well documented. Every one of them that I've come across usually has a way of documenting or doing items. Most support some form of logging, which is really nice because things like Hudson can show you the console window when they're building. You can suddenly something stalled, you can go look at it and see why. Good error handling and reporting. So when it does fail, does it give you an error? especially when you have in your build scripts things that delete folders and build structures out. Somebody going across the network to debug a problem might have left a file mapping into a folder, and they have it sitting up in their Explorer window, and our build scripts are trying to delete the folder that they've got displayed, and it's locked. It's nice to know that the error message pops out and says, could not delete this folder, and it tells you that very plain. Then you just either go onto the machine and kick the user off the machine, or go around and slap somebody's hand. Build all your distribution flavors. I mentioned demo mode, things like that. Again, consistency with your build. Have multiple project maintainers. There's a classic case of having the build master. I've really tried to avoid it. We always end up having somebody who's a little bit better at it than some other people. But by having multiple people who can manage and get into the build server, anybody who sees a breakage can go in and fix it. And it's not. And sometimes it may be your code. Sometimes you added something new, and now the build scripts are not taking that into account. If most people can at least get their way around the build script, they can do the initial level triage and maybe fix it. Apply static code analysis and other tools that can validate your code during your build. There was a comment earlier in the previous session about using find bugs. Find bugs for Java is one of my favorite tools. It basically has patterns built into it that'll find common coding problems. The two that are my favorite is resource leaks. If it sees you open something that looks like a resource and it doesn't see it close, and there's a code path that's not there, it'll flag it for you. Save me. Not often, but every now and then. The other thing that it has a pattern for that's nice is if you lock something, so I do very heavily multi-threaded apps. If you lock a resource and you do so inconsistently, it will tell you that as well. Those two patterns alone, in my mind, are worth using that. There's some similar stuff out for C#. Most of them are commercial. I am expecting more to come to light as Microsoft Roslyn project sort of gets out there. For those that don't know, Roslyn is basically turning the Microsoft compiler for the .NET stuff into itself a service so that you can drive it, you can introspect it. Because once you can introspect the code, you can walk paths, you can ask questions. You can basically scan code and go, where could there be deadlocks in your code? I've done that before, and sometimes it's painful. You can write code that'll walk your code trees, finding deadlocks. Deadlocks are nasty little problems, and often are usually caused, in my mind, by error handling. The traditional problem that I see is that as you tunnel your way down to a piece of functionality, the error handling might bubble up, piece of hardware is failing, something else is going up, and they clash. You end up with a case where you've got two locks intermingled and then you're posed. Profile your builds, I mentioned that already, and for bonus points, support distributed builds. I've become a big fan. So I was already starting to get into job configuration. If there's any questions, please, at some point, just interrupt me. So we talked about configuration. Post-build, I'm invoking Ant. In this case, I'm running Ant. I'm telling it to do a complete build. I am telling it to do verbose. I always have things emit things with all the detail about what they're doing. That way, when they fail, you've got the data. I find it didn't save enough with the console output that's there. I've also installed the Ant performance listener so that as part of the dump at the end of the build, it'll tell me where the task time is taken. We do a bunch of other little things that we found useful at times at different stages of projects. These are, again, plugins to Hudson Jenkins. First one here is scan for open tasks. So this concept of what it does is go scan these files. They can be anything, as long as they're text files. In our case, this is a C# file, so scan all the CS files in the project tree. And go tell me if you see any of these keywords and flag them into a report. So, how many times have you seen to-dos that sit around forever?
Oh.
And we still do, and you watch when you go look at my report. It's pretty interesting. So, open task trend, that would be this. So this is what this is saying is we've classified our nomenclature into 3 keys. The red ones are the important ones, so what is there about there? 80 minus 1, 60 of them. And then we've got almost 80 of the medium ones, and then the green ones we'll never get to. Those are like a wish list. I'd love to come back here one day and take a look at this. What this tool will do for you is actually just scan through the code. So let's say we want to go look at this. So I don't know, I'm just picking stuff at random. We'll see if we get what kind of weird stuff pops out. Hopefully nothing I've seen. So this is some case here, a class called participation DS, which I'm assuming is call interaction or some kind of interaction in the data store. So to do, this is the comment that goes after the to. These need to be able to be configurable and saved somewhere. Disable the take button, the QBU updates indicated. So things that are outstanding. What I will try to do is periodically before we release, we'll go on essentially a session, sit down with the senior developer, we'll walk through and see how much of these things are real. A lot of them may not necessarily be real, because we're passing all the acceptance criteria and all the test cases. So the question is why are these here? Why did they get left behind? Are they temporary or are they more permanent? But you can actually, again, if you actually click on them, it'll actually bring up the source code. You can actually look at the line in question. This feature at times has been very nice. The scary ones are the ones you go looking at the horror scary ones. The warnings. Let's see. Shouldn't call retry media async on a transfer failed when creating an outbound call. Oh, here we go. Ignore this test when functionality exists. So that's basically a case where we know there's a feature coming at some point in the product. We can't deal with this right now because we literally haven't gotten that far in the product backlog. Localization, yeah, there's a classic one. So, clean up, add unit test. Oh, so my team,